10's project is Surface Area Impact on Water Evaporation. This project aims to understand the relationship between the surface area of a container and the speed of water evaporating as the surface area changes.
Hello, I'm Hamir. Our group's hypothesis is that the surface area of a container will affect the speed of water evaporation. Specifically, we predict that water in a container with larger surface area will evaporate faster than water in a container with smaller surface area.
Hey everyone, my name is Angel, and I'm going to talk about the experiment real quick. So the whole point of the experiment is to see if the surface area of a body of water will determine the rate at which it will evaporate. So the way we're going to do that is by using different size containers, and we're going to measure out the same amount of water and see if they evaporate differently under the same conditions. So our material list, we're going to use a plastic tote, a heat lamp, three different shape size containers, timer, some ping pong balls, 200 milliliters of water, and a beaker. So for the procedure, we're going to get a plastic tote, and pretty much that's what's going to house the experiment. We're going to measure out 200 milliliters of water and put it in the container. We're going to put it under the heat lamp, wait about 30 minutes, time it out, and then measure to see how much water evaporate. And we're going to do it for each of the three containers. And then after we get our results from the three experiments, we're going to put ping pong balls in them, and we're going to run the same experiment with the same containers. And we're going to see if the ping pong balls pretty much change the evaporation rate. So here's a picture of the three containers. They're all different, sizes. There's the beaker. Here's the tote with the heat lamp, 200 milliliters of water. So pretty much pour the water into the container, put it under a heat lamp, let it sit for 30 minutes, and measure to see the difference in the water. So we ran that with all three size containers. And then here you can see that we put ping pong balls in it and then did the same thing, 30 minutes. And we did that with each of the three containers as well. And here are the results. So as you can see from trial 1 and 2, the smaller container lost the least amount of water. Large container lost mostly more water. Based on the average, you can see that the large container lost more water. And then with the ping pong balls, you can see that the ping pong balls did make a difference. Each container lost less than the original trials. And I also included the surface areas. So you can see that the smallest container had the least amount of surface area and the large container had the most. And then you can also see how much surface area the ping pong balls took up.
Hi everyone, I'm Shriti and I'll be going over the data analysis and conclusion. As Angel shared in the previous slide, we saw a general trend of more water evaporating as the surface area increased when we took a cursory look at the data. When we compare the data by looking at percent differences of volume change across each set of trials, we see that the small container with the smallest surface area had the least amount of evaporation. And we can see that as we look at the percent differences. Here, we kept the ping pong trials separate to show that this held true even when the surface area was being disrupted by the ping pongs rather than the innate surface area of the containers. Interestingly, the surface area of the round and large containers, despite being about 15 square centimeters different, we're not really seeing as robust of a percent change in the volume of water evaporated as we were seeing between the small container versus these two larger ones. And so in order to sort of get a more robust look at this data, we decided to look at it in a different way by computing the 95% confidence interval by container. And this encompassed trials 1, 2, and the ping pong trial. Yeah, just to show the overall effect. And again, we're seeing that the small container with the smallest surface area retained the most water when exposed to the same heat source for the same duration with the same initial volume of water. And it's also clear that there's not very robust difference between the amount of water conserved versus evaporated between the round and large containers. And we can see that maybe easily through the visual here. And so this brings us to our conclusion where we overall observed and obtained experimental data that showed that the small container saw the least water evaporated compared to containers with larger surface areas when the initial constants or the initial conditions were being held constant. Our hypothesis that the amount of evaporation increases with increasing surface area held true when comparing the small container to the round and large containers. However, again, despite there being a 15 square centimeter difference in surface area between the round and the large containers, we didn't see as dramatic of a difference in how much water would be evaporated. And this brings us to some of the considerations that we have for future experiments to sort of build on these results. One consideration is whether this is an effect of the phenomenon that we were trying to understand having some sort of diminishing value at a certain point. And so, trying to figure out where that point might be. And in order to do this, and if that exists at all, if that diminishing effect exists. And so, in order to do so, we would need to redo this experiment, but with more surface area points to understand this a little bit better, and see if the effect does drop off after, a certain amount of surface area for the volume of water that we were testing and for the heat conditions we were putting it through. And another experimental consideration for us to consider is how we're maintaining our system when we run this type of experiment. Here we use plastic containers and a plastic tote to house our experiment, and in the future we can consider different materials and potentially different effects that result from, using different material types. But yeah, thank you so much for watching our presentation and staying engaged with it. Yeah, thank you.